प्यारे बच्चों, today we will start next part of the operation of the differential amplifier, that is operation with differential mod input. So this is the next part. In last lecture we have discussed operation of differential amplifier with common mod input. Here we will discuss operation with differential. So first circuit, how this circuit operates. So obviously we have two MOSFETs here. We are considering MOS differential amplifier. So we have two different MOSFETs. Q1 and Q2. At drain we have two resistances, similar resistance RD, and supply is VDD. And gates or here source are common. We have a constant current supply with bias battery, and now in common mode operation we have both gates are common, but in differential mode operation we apply input. One terminal is grounded and another is applied with a voltage VID. So this is the differential model. Means one terminal is grounded, another is applied with differential model. So what are voltages here? We have VGS1 at the first transistor, and here you can assume this is the VGS2. We have two voltages here. This is suppose VD1, or you can say like this. This is the VD1 and this is the VD2 drain voltages. Now how this operates? So what is the differential input? In this we have difference of two, that is VGS1 minus VGS2. This is the difference of two gates are there. So difference of these two terminal voltages is called the differential input. Now how it operates? So suppose first case, when this is positive, means greater than 0, positive value of VI, then obviously this voltage is greater than second one, and due to this ID1 is greater than ID2, because these two currents ID1 and ID2 are dependent on these voltages VGS1 and VGS2. Due to these two voltages, since VGS1 is greater than VGS2, therefore ID1 is greater than ID2, and VD1 is less than VD2. Why? Because VD1 is VDD minus ID1 RD, and VD2 equals VDD minus ID2RD. So if ID1 is greater than ID2, then obviously this is less than VD2. And this differential output voltage VD2 minus VD2 is greater than 0, that is positive. So if differential input is positive, then we can say differential output is positive. VD2 minus VD1, suppose this is, we are taking output here as VD2 minus VD1. Then when this is greater than 0 or positive value, then this is positive. Similarly, we can see for negative value how this operates for negative value. So just opposite of this, if suppose this is case 2, if applied differential input is negative, then VGS1 minus VGS2 is less than 0. Okay. What will happen? I see, you can say this is the, for negative value, VGS1 is less than VGS2. Therefore, ID1 is less than ID2, or VD1 is greater than VD2. Therefore, differential output, this is smaller, this is negative. Okay. So for negative differential input, this is negative. So this is the case. Suppose now this VGS1 is increased. Suppose this differential mode input in one direction is increased. Suppose we are increasing it positively. Then what will happen? This current will increase and this will reduce. As this voltage increases, differential input, suppose positive value of this is increased, then this current increases and current in second transistor reduces. And at one time, this whole current, this is the current, this is divided into two parts. This whole current I will flow through this transistor and current in this transistor will become 0. So for this case, suppose this is the case when whole of the current, suppose current I flows through Q1 and current through Q2 is 0. Okay. Means as this increases slowly, this whole current will flow through this and current through this transistor will become 0. And what is the condition for this? For this condition is condition for this operation. This voltage becomes threshold voltage. First thing, VGS2, this becomes threshold voltage, minimum value. Because to conduct this transistor, this VS2 must be greater than threshold voltage. So this becomes at the boundary value. So, or we can say Vg minus Vs, Vg2 minus Vs equals Vt, and Vg2 is grounded, or Vs equals minus Vt. This is one condition. When current through this transistor becomes zero, this value of voltage VGS2, this must be equal to threshold voltage, and from here we can find out the source voltage. This is the source, common source is there. These are drains, these are two gates, and sources are common. So this is source voltage is minus Vt, and for Q, when whole of the current flows through Q1, this current through this transistor is I. Therefore, we can write I equals Q and S. This is VGS1 minus VT, or VGS1 equals VT plus under root twice I divided by this E and dash W upon L, or VGS1 equals VT plus under root 2 VOB. This is the override voltage. This part is override. This. So VGS1, which is the drop across this first transistor, is VT plus under root 2, because whole of the current flows through this transistor. So from current equation we can obtain this value. So this is the value of VGS1, and now we can see what is the maximum value of VID. VID maximum. So maximum value of this VID, which steers whole of the current through Q1. See, this current totally flows through Q1. So for this maximum value is, this is the maximum value, VGS1 plus Vs. So you can write this is the VGS1 plus Vs, and VGS equals this much. So you can also write VT plus under root 2 VOV plus Vs, and plus Vs means minus Vt. So what is maximum value? This is simply under root 2 VOV. So this is the maximum value of differential input. Okay. So this is the maximum value of differential input in one direction. Means when value of this differential input becomes under root 2 VOV, then whole of the current will flow through this transistor. This is the maximum value of it. And at this value of VID, current through Q2 becomes 0. And in opposite direction, so this is in one direction. When VID is positive, so for positive value of differential inputs, this is the maximum value. Okay, so this is the maximum value, and in opposite direction, similarly we can say when VID is negative, then minimum value you can say. This is the in opposite direction. This is minus root 2. Okay. This is one direction value. So in opposite direction, when this becomes negative, current through this transistor reduces and current through this transistor increases. As we increase this value in negative direction, whole of the current will flow through this Q2. So range of operation for this is differential input varies between minus root 2 VOB to plus root 2 VOB. So this is the range of operation for differential mod input. Okay. So this way you can see how this operates, and all of the current will flow from one direction to another. So this is the operation of the differential amplifier with differential input. So now we have seen how this differential amplifier operates with differential mod input. So what is the procedure to see the operation of this differential amplifier? So one terminal is grounded, at another terminal we apply a differential input. So in this way we have a differential input, and as this VID increases in one direction, current through this increases, and when VID increases in opposite direction, then current through this increases, and at limiting value whole of the current will flow through this, and maximum value of VID is under root 2 VOB. Similarly, in opposite direction, this becomes minus root 2 VOB. At this value, whole of the current will flow through this. So this way we can switch operation of current from one direction to another. So this is used in switching operations also, because we can switch currents from one transistor to another transistor, and thus we can obtain a differential output here, because current changes from one direction to another. So differential output, this is the differential output, also varies. So we can get a variable output here due to these two varying conditions, V2 minus V2. So this is all about differential mode of operation. So in next term we will discuss some problems and other parts of this differential amplifier. So this is all about for today. You can revise two modes of operation: common mode of operation for differential amplifier and differential mode of operation for differential. Okay, thank you.